My name is Pamela Hill. I'm a developer advocate at JetBrains. Welcome to my talk called Exploring the Kotlin Multiplatform Ecosystem. I'm from South Africa, Afrique du Sud. I hope I pronounced that okay. And let's get started. So today we'll be going on a little adventure exploring the ecosystem. And my hope is that I can make you so excited about Kotlin Multiplatform that you'll want to share what you've learned with your colleagues and your communities. If I can see like a few talks coming from this talk, I'd be super, super happy. So these are my topics for today. Most apps have some form of networking and some form of persistence, and these obviously need to be done asynchronously. And because we're good, upstanding folks, our apps need to use some form of dependency injection. But, of course, we need a little few of odds and ends like crash reporting, good crash reporting, of course, and logging. And these are kind of broad topics, but don't let this fool you. The Kotlin ecosystem, Kotlin Multiplatform ecosystem is going to surprise you and impress you with its ability to do these things like super, super well. So let's get started with networking with one of my favorite multi-platform libraries called Ktor. So perhaps you've heard of Ktor before. Who's heard of Ktor before? Who's heard of the Ktor client before? Oh, okay. So perhaps you've heard of Ktor before in a server context, but it's actually more than that. It also includes a powerful multi-platform client that is perfect for using in your Kotlin multi-platform apps. So it's not just a highly configurable REST client, it can also do WebSockets and protobufs as well. And when you set up your Ktor client, you have to configure it with a platform-specific engine that is going to process the network requests. There are different engines for Android and iOS, and you configure what you want to use in your Gradle build plugins, your build files. You can further configure it with plugins that will add common functionality like content negotiation and serialization, and I'll be explaining exactly what that is a little bit later, and security, WebSockets, and so on. So our first demo app is going to be from the tutorial on the JetBrains site that shows how to create a Kotlin multi-platform app that uses the libraries Ktor and SQLite. Both are open source libraries. And we'll be looking at a lot of open source libraries today. So the app gets data from the SpaceX rocket launch APIs using Ktor and then shows it on the screen. And it also uses SQLite for caching, but we're not going to focus on that today. So if you want a good introduction on how to use Ktor and SQLite, snap a quick picture because that tutorial is really, really great to get started with. Before we get started, before we actually start using Ktor, we actually need to set up a way to get our data from the API to deserialize into Kotlin objects. And we do this with the help of the JetBrains library called Kotlinx serialization. The first thing we need to do is really have a look at the data from the API and sort of create a similar data structure in Kotlin. To get Kotlinx to deserialize correctly, we need to annotate each class of the data structure with @serializable. If we want to rename a JSON field to something closer to idiomatic Kotlin, we can use the @serialName annotation, and we can also set up that plugin in the Gradle build files. Now we need to create a class, and we're going to call it SpaceX API, that the rest of our application can use in order to access the API. This class has a HTTP client property, and we're going to look now at how we're going to set that up. So we use the Ktor client DSL to create the HTTP client and configure it to consume our JSON. So just like Ktor server has a specific DSL, Ktor client also has a DSL. And so here, the content negotiation Ktor plugin is set up. So content negotiation is going to look at the string coming back from the response and say, hey, this is JSON, let me convert the JSON into Kotlin objects. That is what content negotiation is. It's a big word, but it's actually a simple concept. And It uses Kotlin X serialization to convert the JSON to Kotlin objects here. And Ktor supports many different data formats, not just JSON. Next, we need to create a function that the rest of our application can use in order to access the APIs, and we're going to call it getAllLaunches. And to get all the launches, we call the HTTP client's get function, and then once we've received that response, we retrieve the body, and Kotlin X serialization will return that list of rocket launch objects to us. So a question I often get asked, especially by Android developers like you, is there a multi-platform library that is similar to Retrofit? Maybe some of you, or most of you, are probably using something like Retrofit, that they can use with Ktor. And the answer is yes, there's a library called KtorFit. Let's have a look and see how we can make our code look a little bit more aligned to what we have with Retrofit. So first we need to update our SpaceX API class. It's now an interface that has a annotated function declaration. So here, instead of calling the function.get, we're just annotating with @get and giving the path launches to this function. And then we need to introduce a new class called SpaceX SDK, and it takes the place of API for enabling the rest of the application to get access to the API. And it's going to be responsible for setting up KtorFit and the API and providing all the functions that we call to get the data. So here we're using it to create and set up KtorFit. It's another DSL. And we're giving it a base URL, HTTP client setup, which is exactly the same as what we saw in the REST client section, and a response converter. Now note, there is also a flow response converter, not just a call response converter. So the KtorFit also supports flows, which is pretty nice. And then to create that API, we call KtorFit.create with our interface, and KtorFit will do the rest. Finally, we need to provide our function, and here we're just calling API.getAllLaunches. So I think this is a really nice approach because we're separating how we are calling our API from what we're actually calling. And I think that as your API grows and becomes more complex, things will still be maintainable. I know that when I was an Android developer, which is not too long ago, I was always looking at the API interface to look up call details quickly. Maybe you do the same, but I put my breakpoints in the SDK part of my code. So let's have a look at WebSocket next. Who's using WebSockets in their application? Just a few. Oh, not too bad. Okay, great. So my colleagues at JetBrains, Svetlana and Anton, recently developed something for Kotlin Conf, and it is a chat app. And it was basically just to illustrate some Kotlin X libraries. And it's basically what you expect from a chat app. So you can send a message to your friend, and it shows as a received message on your friend's side. You can also watch your friend sort of typing and aimlessly wait for them to finish and send the message, and sometimes it gets quite annoying, but anyway. And we're basically going to use this example now and look at how we can use Ktor as a WebSocket client. So first we need to configure the HTTP client with a WebSocket plugin. Just like we did with the content negotiation plugin, we're now going to configure the HTTP client with a WebSocket plugin. And here we also need to we have to specify a content converter. Next, we need to open the session, giving the method, the WebSocket method, the host name and port, and the path for the WebSocket. And then we have a couple of options. We can either send events or chat events to our friend over the WebSocket via the server, which is quite a mouthful, using the send serialized function. But we also want to hear from our friend. So we set up the app to observe the incoming events as a flow, as a Kotlin flow. And you need to use the content converter here to deserialize the events that's coming from the server. Finally, when it's time to end the chat, we of course have to close the session as good upstanding folks. So the last thing I want to show you about Ktor is protobufs, or protocol buffers. Maybe you're using it at your company or you've heard about it before. So protobufs are Google's language-neutral, platform-neutral way of serializing data, and it is more efficient than JSON. So the structure of your protocol buffer data is sort of defined in a .proto file, which basically just says how the data coming through should look. And to use with a Ktor client, we actually need to do just one or two simple steps. First, we need to use Square's wire plugin and library to deserialize, to basically generate our Kotlin classes from that proto file. And then, just like we had a JSON as a serializer for the content negotiation plugin, we add protobufs instead. And then that's really all that is. We can send and receive protobufs just as simply as we would of JSON. And something interesting to note that I discovered somewhere in our documentation was that there was a generator that will take your Kotlin classes, you annotate it a little bit, and then it will generate the proto files, which are kind of like tricky to sometimes write up, and it will generate it for you. But note that this is still experimental. Right, persistence. So persistence is a pretty broad topic, right? So I'm just going to give a little taster of each library that we'll be covering today. We're going to be looking at everything from simple key value storage solutions to databases that sync with the cloud and all kinds of other solutions. So multi-platform settings from Russell Wolf is exactly what you need if you need to store key value pairs in a platform-specific way from your common code. So for Android, this will be, you'll be using shared preferences under the hood, and for iOS, you'll be using NS user defaults. What I really like about this library is the way that it allows you to write more idiomatic Kotlin code. For example, the way that it handles nullability is much nicer and less Java-y than shared preferences. The library contributors are also experimenting with adding coroutines and flows. So it would be to deal with and observe, where the platform, of course, allows your settings as coroutines and flows. And they're also experimenting, something that I'm personally very excited about, is with dealing with the iOS keychain, something that I found really intimidating before. So the key interface for multi-platform settings is called Settings. And you're going to code to that interface, as you do, to get and set your key value pairs in storage. Now, the typical way that you're going to get a settings is a class from the library that will delegate its calls to a platform-specific implementation. Now, you could provide it. You basically provide it in your iOS main or your Android main, and then you provide it to your dependency injection framework. And what a coincidence, of course, we're going to be talking about dependency injection a little bit later. So on Android, in Android main, you're going to provide the following to your dependency manager. So here, you're getting the default shared preferences. And then you provide it to the multi-platform settings class called shared preferences settings. And it will delegate all its calls to your shared preferences instance. On iOS, you provide this in iOS main. So you're going to provide user defaults.standard to the multi-platform settings class called NS user default settings. And it will delegate all its calls to NS user defaults. So to use it from common main, you code once again to the settings interface. It looks a lot like Android's shared prefs, but there are a few differences. For example, the way that it handles nullability is a lot better. So here, getString won't return a null, whereas here, getString or null might return a null. Now, a little shout out to our friends at Google. They've recently launched an alpha version of Jetpack Data Store that is now multi-platform. It is also a key values pair storage solution that you can look at. So if you like keen on alphas, this is your thing. Next up, we have SQLite. Has anybody heard of SQLite? There was a really nice talk by Jack Wharton not too long ago. Great. Well, it was actually quite a while ago. It was before the pandemic. Okay. So SQLite from the lovely folks at Square is a plugin and library. It's not a database, but it generates type-safe Kotlin APIs from your SQL statements at compile time. It will also verify your schema, your SQL statements, and your migrations for you. And there's also an IDE plugin that, of course, is an IntelliJ idea. And it will help you write and edit your SQL by providing auto-completion and refactoring. So in the multi-platform scenario, SQLite works with SQLite, which is also multi-platform. So you can use SQLite on Android and iOS. But there are some platform differences in how you access SQLite, and so SQLite has different drivers for those platforms. I'm not going to show you the details, every single detail of how to access, how to set up SQLite, because they have really nice documentation that's also short that will guide you exactly how to do that. I just want to highlight one or two little things for you. So the first thing I want to show you is that there is this SQ file, which SQLite is going to use to create your Kotlin API. So each statement is labeled like here. So here we labeled our select statement with select all launches. And we'll use that label or name a little bit later. And the rest is just normal SQLite flavored SQL. So when our app needs to get all the launches from the database, remember I mentioned something about caching before, it is for local caching, we call the function getAllLaunches on the database helper class, and it in turn uses this property that SQLite provides, and we use that property to access all the queries that we labeled in the previous step. So here we're using it to run our select statement. Onto Realm. Somebody asked me about Realm yesterday, and I said Realm, and they said no, Realm. And I was just like, I don't know how to say that. I'm sorry. Right. So Realm is an open source database from the folks at MongoDB, and it is a really nice database. It's an object-oriented database. It has a couple of benefits, like you don't have these ugly mappings between your code and the database, and you don't have to use an ORM or DAO, your object relational mappings or data access objects. Your code is also much simpler because of the similarities of the objects in your code and the objects in the database. And also your complex queries are also much faster. Now, something that the Realm folks have been working with is, so Realm is both, the Realm is both language, has sort of supports multiple languages and multiple platforms. And so the Kotlin Multiplatform SDK that they provide, it actually allows you to write these beautifully idiomatic Kotlin code that works with coroutines and flows. And something that I needed before in my previous job is to encrypt the whole database with a single key. And they provide that with minimal fuss. You just provide the key when you create the database, and then whenever you open the database, everything is decrypted for you. I think that's a pretty nice feature if you have to protect your user data. But what I really, really like about Realm is how it handles device syncing for you. So this is using their, notice, it's a paid-for product, but it's called Device Sync. And it works with the server-side MongoDB database for your app. And you can have Realm databases on mobile phones, tablets, desktops, even IoT devices, and so on. And Device Sync will actually automatically sync your device's Realm database with the cloud-based Atlas database and the other devices as well, which I think is really cool. So Realm also has an offline first approach. So you can use your app as normally as you could without a network, and then when your connectivity is restored, everything is synced in the background for you. It also has automatic conflict resolution. So the changes that was needed to actually to go from Realm as a local object-oriented database to a cloud-based solution was actually impressively small. And our last foray into persistence is with a tiny little library called KStore. And you might want to look at it if you want to store an object in just a local file on your mobile device. And you basically just give KStore a platform-specific path that where you're going to store your file, but the documentation actually gives you a little bit of a help and so that you know exactly how to do that. So under the hood, KStore uses coroutines, Kotlin serialization for serializing and deserializing the object, and OKR for saving and reading the file. It also has read-write locks and some in-memory caching. So what I really like and what I'm seeing now is these tiny little libraries that are standing on the shoulders of giant libraries like OKR and coroutines and Kotlin serialization, and really creating these great features for us. And I hope that you'll go and think about something that is, maybe a small little tweak of an existing library that's actually super, super useful and that you can add to as a contribution to the community. So in the next two sections, I want to look at concurrency with coroutines and flows. So coroutines and suspend functions have been covered extensively before, so I'm not going to go into what they are or how they work, but what I do want to cover, and I know this is probably something that you're wondering about in your mind, is how to consume them in a Kotlin Multiplatform app. So I'm going to touch very lightly on Android, and I'm also only going to focus on Compose on Android, and then more extensively on iOS. Before we begin, just a little reminder of our demo app. So, of course, to get that data on the screen, we need to get it from a web service, and we need to call that asynchronously so that we don't block our threads. So the stk.getLaunches function was marked as suspend. So if you're using Compose on Android, the key to consuming the results is calling that suspend function. To call that suspend function is to wrap that call in a launched effect side effect, that Compose launched effect side effect. And maybe you've seen that in a few other talks before. So there we see that we're wrapping that function call in the side effect, and then that is going to cause the recomposition of the pull to refresh rocket launchers composable, which is quite a mouthful, and it consists of just a pull to refresh control and a lazy column list of rocket launchers composables. Now on iOS, things are tricky. Okay, so suspending functions aren't a Swift or Objective-C concept. So they're represented in the Objective-C headers as functions with callbacks or completion handlers. So in the iOS app, we actually have this function. We have this published variable called launches. You can see that on line 3. And it is going to be displayed via Swift UI onto the screen. And it has 3 possible states. So it's loading, result, or error. So ideally here, so this is our completion handler solution. So ideally here, we would get some data in launches, and then we would create a little wrapper, a result wrapper for that launches data, and set that published variable to that result enum. Or if we get an error, we would do kind of the same. We would wrap it in an error state and then assign the published variable to that value. So this approach actually has quite a number of disadvantages. Now, firstly, if there are multiple suspending functions, this can quickly descend into callback hell. For example, if I see if there's multiple suspending functions that you want to call, it's quickly going to descend into it's going to be very difficult to read. We're also not supporting the cancellation of these asynchronous operations. Instead, we're waiting either for a timeout or the results to return, and that's a really bad use of system resources. So I want to go through 2 or 3 other approaches to improve this. So firstly, who's sort of iOS and has heard of the async await mechanism before? Maybe your co-workers have spoken about it before. Great, okay. So it is supported in Swift 5.5 from iOS 13 onward, and we can also use this mechanism in our Swift code that will connect or be used, will use our shared code. So first, our view model must be marked with the @main_actor annotation so that all suspend functions will be called on the main thread, because we can only do that in Kotlin, we can only do that on iOS from the main thread. So we need main thread safety. Then we wrap our task in a code in a task that supports concurrency, and then we can also use the await part of the mechanism to wait for the results from the web service. We also do a little bit of error handling here. So this does read better than our completion handler solution, right? But the cancellation support is actually still not possible with this solution. While it's possible to call the task, to take that task handle and call .cancel, it doesn't actually do anything. It's just a stub. Oops. Okay, so how do we actually go ahead and provide cancellation support? Now, the first solution you're probably not going to like. I don't like it either. It's to create your own wrapper that will support cancellation support. So you can look at this article. I'll give you a moment. If you're really adventurous and you want to write your own wrapper, go for it. So this is an article from TouchLab, and you can look at that article for inspiration. If you don't want to do that, there's always another approach. So we can have a look at KMP native coroutines. So there is no official recommendation at the moment from JetBrains on what to do, but the community has provided at least one solution and that is open source, and at least one solution that is paid for. But we're only going to talk about the open source one today. So the open source one is Rick Clefhuss's KMP native coroutines plugin and library. So the plugin will see that there is a suspend function and will generate this getLaunchersNative function for our suspend function. You can see it over there. And we combine it with the library's async function in a way that is similar to our previous async await approach. And this will make our operation cancelable. So this works with async await and combine and RxSwift approaches to concurrency. But you have to remember to use that @main_actor annotation, or you're going to get a warning or even an error. Ooh. So by now you should have heard about flows before. If you're not already using them in your Android application, who's using flows in their Android application? I won't ask who's using live data. Shame. A very enthusiastic person in the middle about live data. Yes. Okay. So if you haven't heard about flows before, just in case, it's a type of asynchronous operation that can emit values one after each other instead of suspend functions that can only return one value. So previously, you had the choice of live data or ArgsJava, both of which have their issues. But for Android, it's now recommended that you replace live data with flows. We'll have a conversation later. So our Flow Demo app is now an enhancement of the app we created in the previous section. In this example, we're creating a flow that still gets that SpaceX rocket launch data, same as before, but instead of returning it big bang, the whole list all at once, it reverses it so the newest data is always at the top, and it makes it progressive. So first we have just one element, then two elements, then three elements. And this is not trying to make it look animated, of course. This is just trying to illustrate flows. So the first step to a solution on Android is to separate out the calling of that SDK into a separate view model. That's just good hygiene, right? So this view model has this state flow property called launches, and we use SDK.launches, and then we use it at the state in extension function that will take that SDK.launches cold flow and convert it into a hot state flow within the scope of the view model. So when we want to consume this view model property in our Compose code, the most important part is, of course, that we remember and collect a state our view model launches property. It is then used to populate our lazy column list of rocket launch items. Now, for iOS, things, of course, become trickier again. Firstly, this is because Objective-C doesn't support generics on protocols. Somebody asked me about this before. So flow interfaces actually lose their generic type value, and this makes it so much more difficult to use these flows safely. We also need cancellation support and main thread safety. So one solution to this problem is again Rick Cleffuss's KMP native coroutines. It's a really nice library. So here again, we use the function called getLaunchesNative to get that flow, and then we pair it with the library's async stream. So it was async function for coroutines, and now it's async stream for flows. And then we iterate over the stream to assign that published variable some values. Again, we need to annotate with @main_actor to ensure that it's main thread safety, and this does support cancellation. It does have cancellation support. Of course, if you really want to have a little multi-platform challenge, you can roll your own, but let's not do that today. So next up, dependency injection. So dependency injection is a really great way to level up your Kotlin Multiplatform app, so it's more loosely coupled and testable. I'm going to present one solution under the flag of dependency injection, but there are a couple of options to choose from, and I'll note them at the end of this presentation. So, of course, the library that I'm going to be presenting, of course, one of our sponsors as well, is Coin. And it's been a favorite of mine for about 5 years. And it is really simple, and now it's multi-platform. And these are the steps that you're going to have to go through to do dependency injection with Coin on Android and iOS. So first you define your modules, then you call start Coin, and then you inject your dependencies. So Coin also has a DSL for defining dependency modules. And here we are defining two dependencies, SpaceX API and the SDK. So the SDK depends on the API, but we can add something like client-side caching, for example. To initialize Coin, we need to call the start Coin function with all the application's modules. So here we can either we define this function called initCoin that we're going to be calling from the right parts of our application. So here we either pass in an argument with app module, or we default to something else. We default to the modules we created before. And in this way, we can either use our real dependencies or some test dependencies. So now we need to call this function in the right part of our Android and iOS applications lifecycles. So that's on app start, so that all the dependencies are available right from the beginning. So for Android, this is pretty easy. We either call it directly from the onCreate function for the application, but for iOS, there's a little problem, a little Swift interop problem. And this is because Kotlin default arguments can't be used from Swift directly, but there is a workaround. So we need to create this bridge or helper function in iOS main to call initcoin. So in iOS main, we create this initcoin app function that just calls initcoin. Then within the iOS, so this is what I'm highlighting here is actually Swift code, and it is the startup of our iOS application. We call that initcoin app function so that it's within the init stage of the app's creation. When we want to use our dependencies, Android, of course, is so much easier. We just use by-inject. But if you want to use it from iOS, you need, again, a bridge or helper in iOS main. And we basically just create a class called SDK helper that implements coin component. And it's just a marker interface. And again, we use by-inject, and then we provide helper functions for all the SDK's functions. And then instead of using the SpaceX SDK, we now are going to use SDK helper. So whenever we pass into our view models constructor, we pass in the helper, and we are always going to use the helper in our view model instead. So if you're wondering what other DI options are there, there's also Codeine from Salomon Braze and Kotlin Inject. Of course, we need a few other little bits and bobs, like good crash reports and development time logging. And I'll explain right now why it's important to have good crash reports. So if you're an Android or JVM developer, you're probably very familiar with this hierarchy. At the top, we have the throwable class, and it has two subclasses, error and exception. Now, errors, like the nasty out-of-memory error, can't be recovered from, but exception, like the inconvenient IO exception, can be recovered from if you catch it and handle it appropriately. But on iOS, this concept is swapped around. So, what? Okay, while you can recover from errors, you can't recover from exceptions. So that's a great change. Thanks, team. Okay, the first really important thing to note about code safety is that you have to be super, super vigilant about annotating your shared Kotlin code with the exceptions that might occur. So in Kotlin, all your exceptions are unchecked, which is really great, but in Swift, they are checked. So if you don't use the @throws annotation and handle your exceptions, you're going to get a crash. So throwables always include a message and a stack trace. So in development, that's true, but in production, these messages and stack traces are actually super unhelpful, and it's usually of the k-abort variety. So what we need instead is something to log all the fatal errors in Kotlin and attach the stack trace to it. So like in development time, you get the stack trace, you get the message, it's all good. But on production, you might just get this very vague k-abort thing. And so what we need is something that will log the fatal errors and have it make sense and attach our stack traces to it. We also want our cause by exceptions to be added and their stack traces. But we don't want that k-abort thing because we know our app crashed. So what we can do is we can use something like NSException-KT. And this is a solution from the community to improve the way that production crash reports are on iOS. And it will make sure that your reports make sense and that it's helpful to figure out what actually caused the crash. And it supports different crash libraries, reporting tools like Crashlytics, Bugsnag, and Sentry. They all sort of vary in how they're actually set up, but the documentation is really solid. So go have a look at the NS exception KT library for the implementation details. An alternative to this is CrashK iOS. It only supports Firebase and Bugsnag, but in their articles and READMEs, the folks from CrashK iOS, which is TouchLab, and the folks from NS exception KT, which is Rick Clefas, sort of credit each other. They kind of worked on it together and then just had their own separate libraries. And our last library is just Kermit, which I think is quite funny, Kermit the Log. Kermit the Rog. So Kermit is an open source library from TouchLab that gives us not just better crash reports, but also logging in general for development time. And in development, you can log to your platform-specific logger, so that will be Logcat on Android and iOS Log on iOS. But in production, you actually want that logging to be completely disabled or even stripped out completely, and you can do that with a plugin. So this library also includes the CrashK iOS by default. Another alternative that you can look at if you're just looking for development time logging is Napier. It does a good job at just logging to the platform-specific loggers, but it doesn't have all those bells and whistles that Kermit has. And then lastly, I want to make a few honorable mentions about some multi-platform magic in the ecosystem. So another really great way of leveling up your skills on Kotlin Multiplatform in a really big and exciting way is learning about Compose Multiplatform. Now, if you didn't manage to catch Sebastian Eigner and Nikita's talk on the topic at KotlinConf, it will be available somewhere in May, and they covered how you can share your Compose code on Android and iOS, and it is so cool. There's also a really cool library that I want to share with you, and if you just take one screenshot, this is it, because it was going to help you find the libraries that you're looking for. This is going to show you the breadth of the Kotlin multi-platform ecosystem, and it's called KMM Awesome. It is a list, sort of like this repository of tools and libraries by my colleague Kostya. And if you're looking for something like cryptography or logging or almost anything, I suggest you look there first, because it's updated regularly and it's expertly curated. He really goes into a lot of depth to make sure these libraries are great. So let's have a look at the broad categories of KMM Awesome. And I'm excited, I always get excited to see what's happening on that page when I browse through it, to see how the ecosystem is growing. I want to just quickly zoom into architectures. So KMM Awesome has a long list of architectures, not just these, but the most prominent MVVM ones is Mocha MVVM from IceRock and KMM View Models from Rick Clefas. If you also want to use MVI, there's also MVI Kotlin and Mobius.kt. Now, I would kind of recommend that you go the MVVM route if you go in greenfields, because of Jetpack Compose and SwiftUI being a little bit easier to use with MVVM. Another last resource is just the Atom or A Touch of Multiplatform podcast on YouTube. So my co-host and I interview interesting folks from interesting companies about their journey on Kotlin Multiplatform. We've had folks from Cash Apps, Jake Wharton and Jesse Wilson. We've had people from Lutron, which is like a lighting automation stuff. We had people from Meetup and all kinds of other people that are using Kotlin Multiplatform in production. So to sum up, Kotlin Multiplatform is now in beta, and it's going to be going stable soon, this year. So the ecosystem is expanding rapidly to cover all kinds of multi-platform use cases, and it's ready for use in production, and I hope that you'll give it a try in your apps. The last thing that I wanted to mention is just a big thank you to all our open source sourcers and sorceresses for expanding our ecosystem. We can't do this without you. If you're here and you're doing like open source work in Kotlin Multiplatform, please come say hello. I want to hear from you. And if you are developing in Kotlin Multiplatform Mobile as well, I want to hear your story. And of course, because we're at a conference, and what will a conference be without swag? I've got Kotlin stickers. I'll put them over there. You can help yourself, have fun, and thank you for your attention. You've been an awesome audience.